My name is Don Wibier. I'm Technical Evangelist with DevExpress, and I hope I can give you some more inspiration on maybe some optimizations in your own code. I'm going to be talking about generics and abstract classes in C#, and typically not on how to use existing generics and abstract classes, but how to set up your own generic classes, how to deal with that, and I'll show you how you can actually optimize existing code. So I'm going to be showing you some code, and I'm going to refactor that, and you'll see that there is a lot of redundant code gone at the end of this session. And I hope I give, that'll give you some inspiration to take a look at your own code, and maybe you can put in some optimizations yourself. So let's first start on an abstract class. And by the way, this code can actually be applied on all sorts of C# projects, whether it is Blazor or .NET or .NET Core, or it's a generic thing on the .NET framework or in the C# language typically. So let's first start on what is an abstract class. Well, is there any of you that didn't use an abstract class before? Most of you did. Cool. All right, so it is typically a class which has a declaration, but doesn't have an implementation on a specific member. So it is also typically a type which serves as a base for a class hierarchy, and it cannot be instantiated because it's obviously not finished yet. A simple example to freshen up your minds a bit. I have a bit of code here, and what you'll see is I've got a shape which is marked. The class itself should be marked as abstract here. And it's got an abstract property in this case, which is called the area. So that one is abstract as well. In the toString method, I'm actually using that area property. But I don't know at this stage what it is. So if I would scroll a bit down, I will now have the rectangle shape, which is derived from the shape. And what I've done is I have implemented that area property, which is in this case the width times the height. So it's pretty straightforward. And I didn't need to redo the toString method. Well, same goes for a circle. As we all know, the area of a circle is calculated different from the rectangle. So this is in a nutshell what an abstract class is. And you can apply this on methods, properties of a class. But what you'll find is when you combine this with generics, you'll see that the design time experience inside Visual Studio as well as Visual Studio Code gives you quite a couple of really nice features that enables you and your code developers to write code more efficiently, because it's all, very, very nice done. But you'll see that a bit later. So let's take a look at the generic type. So what is generics? Well, it's more like a coding template. So you can define a class which holds some types that you might want to change later on. So maybe it's got like a property of a specific type, but in a descendant class you might want to have another type of that particular property. And what we can do is we can create some sort of a code template, a compiler code template. And it is, once you master this technique, it is a really efficient way for reusing code in a type-safe way. And that is one of the most important things, because that saves compile time errors, because it is all strongly typed if you set it up properly. Well, obviously this is giving you a compiler error. And this is considered to be type safe because the compiler will already complain. You're declaring an integer and you're trying to put a string into it, and that will obviously not go. An unsafe way of getting rid of this issue is by not declaring that variable as an integer, but as an object, because you can store everything in it, but then you'll lose a couple of great features inside Visual Studio. Because now Visual Studio, yeah, you can do whatever you want. Visual Studio won't complain, but you'll encounter runtime issues, right? And with generics, you can solve that really, really nice. And also the compiler and the .NET framework deals very efficiently with generic types. There are other languages and development environments as well that have generics, but yeah, I mean, the C# or at least the .NET runtime is dealing very efficiently with it. So it will actually treat it as a generic class, and it will only at runtime instantiate a class where you specify the generic, and it will not do a lot of overhead for that. And that's something which is really cool. Well, I'm pretty sure that all of you have been dealing with generics by now, because obviously the .NET framework uses a whole bunch of generics, only to start with the startup file where you configure all kinds of things. That is typically all using generics. The list of T is a much used thing that is generic as well. I mean, you can put whatever type in this list. But what we're going to talk about is how we can create our own class which will use generic types as well. A tuple is an example. The function and the action are really cool things which are used quite a bit in the internals of the framework as well. And then obviously the dictionary is a great example of generics as well. And with the later versions of .NET Core, there is the span of T to deal with memory allocations and so on. Well, as I mentioned, the configuration file, let me open up my Visual Studio and show you a small application here. Yeah, so if we can see, this is the program file. Now I should actually use the startup file for this. And what we see is there is a whole bunch of generic stuff going on here already. Configuration of entity framework, a whole bunch of other things. So yeah, it's really, really, really a good thing. All right, so yeah, let's see what we can do to create that generic code. And let me see, yeah. Let's switch over to Visual Studio now. All right, so what I've done, I've set up a small demo application, and the application is set up to be using Entity Framework. It's nothing exciting there. I'm connecting to the Chinook open source database, which holds some music, some invoices, and some other stuff. And I have obviously, since I work for DevExpress, I've used our DevExpress project template to set up this application. So this is, in a nutshell, how it looks. It got a bunch of invoices here. I also you can actually edit those invoices, but that's not really a thing here. I have customers as well. And how did I set this up? Well, I have used one of the things that come with DevExpress, which is a scaffolding tool. I will show you how that works, but then we will redo the whole scaffolding part in making it generic. So the way that I did this is I went to the controllers. Let me see if I got the right project. Yeah. And I will be adding a controller. In this case, I'm going to be adding a DevExtreme API controller, which comes with our product. And now, because I've set up Entity Framework already to connect to a certain database, I will be able to pick any of those entities, create a controller. And what it now does is it has created a complete web API controller for me to perform CRUD operations, so I can I can get the data out of the database, and I can also post, put, and delete. And as you can see, this has been scaffolded, and obviously scaffolding can be really cool because it can save you a lot of time. But if I would take a look at one of the other controllers that I already scaffolded, for instance, the Invoice Controller, you will see that because it's scaffolded, it's all pretty much the same. It is all pretty much the same, but slightly different, you see, but there is still a lot of code involved, and I mean, it's a lot, but obviously, that's one of the things with scaffolding. I mean, it will poop out like a whole bunch of code in seconds, and it will save you some work, but once you start developing or expanding your application, you might want to change some of the behavioral things, and you might want to change the behavior of the scaffolding, and then is obviously when the fun begins, because you need to change all the controllers. You need to go all over the scaffolded code, and that's not going to be cool. So this is also where generics is like a really, really nice thing. One of the other things that bothers me a bit about this template, and I mean, don't get me wrong, this stuff is great, obviously, but with such a solution that we offer, you typically don't want to include like a whole framework to go with it. Huh? It's like a scaffolder. It gives you an idea on how it works, and you can start customizing it from there. But if we also would ship out like a whole bunch of base classes, you need to get into that as well. So for this purpose, this is fine. But for like a real application, if you use this for a prototype, it's fine. But if you want to get on with it and create like a bigger application, I would certainly check whether we can change that. One of the other things, which is something which I would not encourage, is the results of this get. This is returning an anonymous object, basically. So there is no design pattern involved in DTO. Maybe you want to perform DTO and abstract that a bit away from the actual data layer. So I typically have like two things to do here. I want to be able to use the DTO design pattern to transform the data entities out of the database into like the objects being returned. And obviously, I want to have less of this enormous amount of code. And so for that, I have also already configured and implemented AutoMapper. AutoMapper is one of the most used tools to perform DTO transformations. And I've already configured that. So in my folders, if you see it in the project folder, I have set up the entity framework models here. I have set up a number of DTO models, which also start with DTO. And I mean, in this case, it's quite simple, but it is just to give you an impression on how to approach this. And what I've also done, obviously, is I have configured the mapping profile for AutoMapper. And it's obviously nice to mention that you can see that also AutoMapper greatly depends on generics. All right, so if you want to know more about the AutoMapper configuration, they've got some excellent documentation. Actually, you can probably still ask the author, because he's on the conference as well. So you can ask him a dozen questions on this. All right, so the first thing we'll do is I'm going to chop up the data access and the actual operation on the web API endpoints. And for that, I have decided to also set up, in this case, an EF data store. And this brings us to our first generic thing. And that is, we're going to create a generic interface. So how do we create a generic interface? Well, this is quite simple. I'm just specifying my interface name, and I can specify a whole bunch of generic types. So in this case, I'm using the T key and the T model, because that can change. Maybe the key type in some scenarios could be like of a type string, or maybe it's a unique identifier, or maybe it's an integer. But this key is an important thing that might be generic. And one of the other things that I've specified is the model. So this interface is going to be implementing a couple of things, which we'll see later on, but we have this key and this model is the DTO model type. But we also want to put up a couple of restrictions, so that the key should be a type which should be able to be compared with another type. In the store, we might need to look up a certain entity for updating or deleting or whatsoever, so we should be able to resolve that. And in that case, it is one of the things that you can do is that you can specify a where clause on your interface declaration. And in this case, I'm specifying that the T key can only be of the type equatable. And what that means is that the key of the objects that we're going to deal with cannot be of a type of a complex type, because they are typically not implementing the equatable interface. So an integer can be put in here, or a string, or a unique identifier, those kind of types. And also the model, that should not be like a simple type, because we are dealing with DTO, so we want to have like a real thing. So for that, I can put in a second constraint on my generic types. And in this case, the T model can only be a type, which is an actual class, so it can't be a string. And it should have a constructor without any parameters. That's the new with the brackets. So yeah, we've pretty much created our first generic interface. We're going to be adding a couple of things later on, but let's do the same thing with the class. And the class is going to be slightly different, because what we'll see here is that I've specified a bit more. And this data store will actually help me. This is going to be something which I can query. I can pass in a DTO object, and it will make sure that it will be updated correctly in the database, or inserted or deleted. And so this is typically my store, and my store is depending on a DB context. So that's also why I have specified now a TEF context together with the key and the model, but also the DB model, because we need to do the mapping and the system needs to know how that works. And so for that, I have now specified 4 generic types. And obviously, it is implementing that same interface. And because that interface has some restrictions put on those specific types, I need to put on the same ones here as well. So in this case, I'm also putting up a restriction on the TEF context, which should be a descendant of the DB context. So we can use this like in other projects as well. The key is the same restriction as the interface. The model is the same as the one on the interface. And this one, yeah, it should also be a class. And obviously, Entity Framework just deals with plain objects. So we can't like make that any tighter, basically. So now we can actually start using our or implementing our generic class. And also, I have made this abstract, because there are a couple of things that in this base class I don't know yet. And we'll find out a bit later what that is. Let's first put in a couple of things. I will be dealing with AutoMapper, and I will be dealing with the DB context. So I'll use Constructor Injection. I've set up AutoMapper and DB and the Entity Framework to be available in the dependency injection. So I will be using the Constructor Injection to get references to it and store them. Then one of the other things that we'll need is a couple of helper models. And this is also something, this is a really simple example on how to use your own generic type. So at a certain stage, I need to create a new model, a new DTO model. And remember that T model, that is a generic type. So instead of dealing with like a real type here, I'm just using one of those T model generic types. And I can actually do this, the new model, I can create a new instance of this type, which I don't know yet. I mean, it's going to be happening in an implementation somewhere. I can use this construction to create a new model because I put up a constraint, this. If I would remove this one, you will already see that I get the red curl, the curly line. So this is one of the great design time features that Visual Studio is giving you. Like, okay, this can't be done. If I can't put up that new thing on the constraints, I should use the activator, create instance, yada, 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 and the whole bells and whistles. But if I now just specify that new in the constraints, and that's, for this case, it's perfectly fine, it's also fine with the compiler. So this is how quickly also Visual Studio picks this up, and it's going away. One of the other things that I'll need, I need to locate an entity in the database by key. And again, what you see here is I'm actually using two of those generic types, which is the TDB model as well as the T key type. And I'm just using it as if they were like real types here. And because of the constraints, I can actually use a couple of things. I have specifically pointed out that the DB model is a class. And I have also specified the DB context of being of the type TDB context. So that means that I can now use the find on the DB context with the generic type that I'm looking for and the key. You see, so this is actually just working with the types that you were already making generic, but instead of real types, you are dealing with these generic types. So let's put up a couple of other things here. This is an interesting as well, because at a certain stage I need to query the data store to select a number of albums or invoices or whatsoever. And with this, I will just follow the approach of Entity Framework and use the iQueryable of type TDB model. And I'll just call the generic method, which comes with the DB context of Entity Framework, and I pass in that TDB model type. And so this is all, not strongly bound to a specific entity yet. So let's see, there is a couple of more things that we'll need, and one of the things is obviously, because that is one of the things I want to query based on the DTO object, but then that needs to be transformed at runtime to the entity framework models, because at the front I'm dealing with the DTO objects. And that is also why AutoMapper is getting quite nice. So this one will actually query based on the T model class. You see that? And I've also made this one public instead of protected. And now I'm actually using one of the AutoMapper features here. And this allows me to query based on the DTO object on the front, but it will be transformed by AutoMapper into the entity framework models. And this is a very cool feature, I'd say, because then you are actually abstracting away the data layer from the front end. A couple of other things that I also need to do, I need to get back to this first one because I will need to add this one to my interface, which I will do right now. Let's see, and this one will need it as well. So I don't need to stop it. So I don't need to do that any later. Yeah, let's Let's put in another one. This is a bit of an odd one, and I obviously did show you the entire code that was scaffolded, but here I am actually introducing a local generic type. So this is also one of the things that will work. In this case, this T is only generic available within this method. And still, I'm also able to put some constraints on it as well. I'm going to use this as well, but we'll get back to that a bit later. But it does show you how you can actually have like this one particular method which allows you to specify another extra generic type. And what I can do now is I can use AutoMapper again to query based on that T type, basically project it back to the entity framework models and then query the database. All right, so this one I should also put straight away to the interface. Let's do that here. So we have done the query part basically, so we now have a generic data store which will do that. I will also want to query and get a model back by key. So in this case, I'm going to be using that create model method that I declared earlier. And I will locate this by using the EF get by key. And the AutoMapper will transform that into that T model type. Okay, so this is still all very, very generic code. And for this one, we should also add that immediately to the data store. Yeah, all right. Okay, so now I'm going to introduce you another generic feature, and this is something that you have used before, I'm pretty sure about it, but this is looking quite complex. Specifically the declaration. So if you take a good look at this, what I am trying to do here is I want to execute some function that's going to happen a bit later on within a transaction. So basically when I want to update any of the entity framework models in the database, or delete it or update it or whatever, I want I want this to happen within that transaction. And the interesting thing here is that this first parameter looks quite complex on the declaration side of things, but this actually is a function which passes in that EF data store with all the generic parameters, and it will return the type, which it returns. But this looks quite strange, but you'll see a bit later in code that this is a very powerful feature that allows you to basically do whatever you want within this function and return whatever you want in this function because of this generic signature. And this is done on a function. I have a similar one. This will not return anything, but it will still do something. Huh? So this, let's go back to this one. So what we do here is I have this work parameter. In this case, it is of a type function, so it can return something. And the other one is quite similar, except that instead of returning this T, this parameter will be an action. So this work will not return anything, but it will just do something within this transaction. But that work is going to be executed here. And then it will do a commit in this case, or whatever. So the declaration looks a bit complex, but you'll see in code how this actually works. So let's go a bit further. Before we can use that code, there is one thing that we don't know yet in this base class. And that is how to set the model key on a particular model. So what I'll just do here is I mark this as being abstract. I don't know what it's going to be. I mean, if I want to update an invoice, I have this invoice model, and it's got an invoice ID property. But if I have an album, it might have an album ID. And so those properties are different, could be different, but I want my code to be type safe. So that is why I am making this one abstract. And in the derived class of this, you will see that it is really not a lot of work to implement it. I'll add this one to the interface as well, and stop, hot reloading. I have another one which will return the key. And it's the same. For the album, it can be the album ID, and for an invoice, it can be invoice ID. And again, I've made this one abstract as well. Then there is one thing, and that's the one to set, to get the key out of the model, because theoretically with DTO, you could be working with the entity framework model, which has an ID field, but maybe you want to have it on the DTO as album ID. So those keys could be different from the model, the entity framework model versus DB model. So I've made this one abstract as well. And now, with these in place, I can create a generic update method, insert method basically. And this also brings us to this transactional execute with the difficult signature to read. So what I am doing here, and this is obviously quite nice, is that this first parameter work is receiving two parameters. I've specified that in the signature above, so check it out a bit later. And this is the code which is going to be executed. And as you can see, because I pass in those two parameters here, I have access to the DB context, I have access to all the things that I need to update that model. And one of the other things that I've done is I have passed in an array of models so I can update like a whole bunch of them in one go. And so this is that parameter of the transactional execute. And in this case, it is the first one that was returning the T, so that is the result. But if you want to do something which doesn't necessarily update or return anything, yeah, you can use the other one. And in this case, the result is a type EF result. There was a little class that I put on top of it. And why is that of type EF result? Because in the end, I'm returning that EF result. And that is why the result, but if I would return an integer, if I would change this return 10, for instance, then that T would be changing in integer. So this already works design time, very nice. And the EF result is just a simple object returning success, true or false. I mean, in a real application, you might want to check which items have been updated and which not, whatever. So you might want to expand that a bit. But all very, very generic still. Well, you can imagine that the update method is doing a similar thing. So I'm not going to spend too much time on that. But what we'll see here is that we look up the model key. So this brings us to this abstract method. I need the model key before I can actually look that up in the database. And if I found it, I will map it from the DTO model into the entity framework model, and I'll save it. Yeah, so again, with that transaction execute method. Well, then the last thing that we'll do here is the delete method. Well, for the delete, we basically only need the IDs. So I thought, okay, I'll do an array of IDs of type TKey. And yeah, pretty much the same. In this case, it will do the transactional execute as well, but it will just locate the models and it will delete it. You see, so Then, because we want to use await and async as well, I have put in a couple of methods which will allow us to async await the same stuff as well. And with this, yeah, we have actually set up our generic data store. So how does this work in practice, basically? Well, if I would now go to the Invoice Controller, I can go to here. No, not the Invoice Controller, the Invoice Store. I've created a class of type Invoice Store. And what I now do, I'm going to create this class. And this is how I am able to implement this EF data store. In this case, it is already specified that I am using the Chinook database context, which I configured. The invoice entity has a primary key of type integer. My DTO invoice is the class that I will be projecting on the front. And the invoice is the entity framework model. And what you also see now is that there is a couple of red squibbly lines. And let's first take a look at this one. There's a couple of typos here. Let me first get these out of the way. I need to change this in the demo side. Okay, so they're all gone. And now they're double. Let's get rid of these as well. All right. So, and this is a really cool feature because you already saw it with the abstract class that I was demoing in the beginning. It is already complaining that something is not cool here. And if I would hover over, what we'll see is, yeah, there is some stuff not being implemented because it was being abstract. And now you'll get a really nice thing. Because if I first say, add a missing constructor, I need the constructor obviously. Stop. Can I just stop that thing for? Okay. Anyway, so I just implemented a constructor, and what you see is that Chinook context is now used as a parameter, so it is now become strongly typed. And we take this a step further, because if I now go again to here and I will implement the abstract class, and this is also quite cool because you know exactly what you're dealing with. This is the only stuff that I need to implement. And if I do this, I have a full data store which allows me to deal with, in this case, invoices. So, well, this is quite simple. And what's also interesting now is that you see that the generic base type has been closed. It's not generic anymore. It is now all strongly typed. This is the model I'm dealing with. This is another model I'm dealing with. This key is an integer because I specified it on top. So it is basic. It's typically a coding template once you combine abstract and generics together with each other. And the only thing I need to do now is I can return, in this case, model, and I have everything available here. So this is obviously very powerful, and it saves you quite a bit of compile time errors. So let's say model dot, well, what was it again? Invoice ID equals key. So now I'm actually dealing with strongly typed things. Let's do this one as well. Return model.invoice ID. And yeah, with this approach, my base classes don't need to inherit from anything that I would need to make this work. No, I'm just dealing with generic types. I now have code completion here on the specific types that I have been specifying. And this is the only thing I need to do. So before we can actually apply this on the application, I'll do the customer store quickly as well. And this is typically, it's not really a lot different. In this case, I'm dealing again with the Chinook context, integer type, DTO customer instead of customer. And yeah, now it's pretty much the same deal. I can just say implement add the constructor, stop reloading, and implement the abstract class. So now these classes only implement code that is specifically for these classes, and you have gotten rid of a bunch of redundant code. Before we can actually apply this on the application, there is another thing I need to do, but I will quickly go over that, and that is the base controller. I've also decided to set up a base controller. And again, I will follow the same approach as I did with the store. The base controller has a key type, it has a model, and it has a store type. So I need an invoice controller, obviously, to deal with invoices. I need a customer controller to deal with customers, etc. So again, I have now specified that this T-store is only of a type iDataStore, of T-key, T-model. So I can't use the customer store on the invoice controller because those declarations don't match. You'll get a design time error that won't work. So this is quite safe, coding-wise. In this case, I will also use constructor injection. In this case, I need the I only need the data store, so let me quickly insert it like this. And there's a couple of other things that I will do. In this case, I expose the data store, the primary key pagination, and the primary key. That is something that was in comment in the original code. That has to do with the remote paging, sorting, grouping, but that is more like a DevExpress thing. I won't go too much over that right now, but I'm just putting it in. Then I'm going to put in the error message, the get full error message, which was something which was in all the controllers, so that was a bit redundant code. So I'm just putting it in here. And another thing I'm putting in here is the populate model. And the populate model is because the controller, the invoice controller, if you want to do an update here, it receives JSON and that needs to be deserialized into a model. And for that, we're going to be using that populate model thing. So just a couple of helper things here. Again, I do want to have access to the create model. So in this case, I could also call the main data store T-model. I don't know why I did that. And iQueryable, I make it available as a method on the controller as well. Now we're going to actually remove some of the redundant code by implementing the get method. And in this case, I'm not decorating. We are now dealing with a controller. So I'm not decorating in this base class the method with HTTP get. I will also not do that with the post and the update and the delete. There was something that was, why is this giving me this error? Should be okay. Let me see. I am on purpose not decorating these attributes on the base controller because maybe there is this one controller that doesn't allow you to update or insert or whatever. So you need to explicitly do that on the actual controller, which is deriving from this one. All right, so with this in place, I still don't know why this is. Do I really need to do it like this? Oh, of course. Yeah. I needed to do the await and async methods. I needed to put that obviously in the interface, which I didn't do. So let me do that right now. Right. Okay. All right, so all those issues have gone now. So I have quickly implemented a generic base controller as well, which is dealing with the store. So I've actually abstracted that original code a bit as well. So you can, you have that separated. And now we can actually start with the fun stuff. The data stores need to be configured. In this case, I will first, in my startup, I will deal first with the invoices and the customers, I think. So now I can use the DI to add my invoice store, which will now be injected in a controller which demands an iData store, which deals with DTO invoices. The same goes for the customer store. So I've now configured my two custom stores to be used with dependency injection. If I would now go back to my controller, we can definitely slice up some code, which is always nice to do. So in this case, I will go to my invoice controller and I will change this to base controller. And as you can see, you will have the full code hinting. I'm dealing with an integer. I'm dealing with a DTO invoice in this case. And the store is going to be my iData store. Let me copy that over from the dependency injection. Where was it? Yeah. Okay, this should be injected, and this will obviously result in the invoice store because I configured that like that. Let's see, and now I can, let me quickly put this one aside like this. I'm not sure why it is now complaining. Yeah, so what you'll see is that I have implemented a constructor and I need to override a couple of things here. This one is still a bit weird why it can't be found. Wait a sec. This is weird. Okay, let me switch. Did I miss something there? Yeah, it must be. Let me get rid of this and let me start all over again here. So I was implementing the base controller and the base controller deals with the integer, the DTO invoice. I'm not sure why it can't find the DTO invoice. Did I? Yeah, I probably didn't got it in the name. Yeah, I can probably do it like this. All right, so yeah, we're back in business. Wow. Yeah. Okay, so I've now specified this base controller, and let's implement the constructor first to get that all set up. Everything is okay here. And now what I can do is I can override, oh no, I first need to implement an abstract thing. Override the get. Why do I need to override the get? Because I need to decorate it with the HTTP. I have decided to do that on purpose because now I can specify per controller yeah, that it should be available for get or something else. Then I will do the same. You know what? I'm going to copy that one over from my finished demo. That saves a bit of work here and there. So the invoice controller is going to look like this. This is going to be way shorter because what I've done now is I have overridden the appropriate methods. And there is one method that needs a bit of attention. I have mentioned that before at the beginning when implementing the store. So let me do it like this. So, and that is the customer lookup. But what we'll see now is that we have actually reduced this entire controller, the code that was in here. So all this code is all obsolete basically. And this goes for all controllers now. So I'm not sure what will be faster, scaffolding another controller or just implementing one of these interfaces, one of these base classes. I mean, all this code can now go away. Because this is the only thing that is left. And as I mentioned, I created this, this query method with a local generic type, remember, in the EF store. Well, and that is because I need a customer lookup to populate in the data grid. You probably missed it when I was showing the application. So what we can do now as well is, because we need a customer store here as well, we can actually expand this one with having a second parameter. Well, let me just show you that in the finished demo because we are almost through our time as well. This was the invoice controller. So what I've done here is I've just used Constructor Injection to get access to the customer store as well. And instead of getting a full DTO customer object back, I just need a simple object. And if I would check this class up, that was already in the DTO classes. It typically just has a value, a first name and a last name, while the full DTO customer obviously has a bit more information. So because of that local type that I used on the query method, I'll be able to use AutoMapper and the configured AutoMapper entities to get another type of customer object back as well. And yeah, so with this in place, you can imagine that you can actually reduce quite a bunch of code. And in this particular scenario, I have reduced it to like, what is it, 5% of the remaining code. And obviously, I have the base classes prepared to be fully generic, and I can actually implement it strongly typed on my actual implementation. And with this in place, what we'll see is, let me quickly put this in so the application runs again. I'll copy this over to the other one here. It's starting. It's So what? Sorry? Where am I missing something? Oh, yeah, you're totally right. Yeah, so, and with this in place, we have typically the same application as before when I use the scaffolding feature with like a whole bunch of redundant code, and the application will still behave the same, except that it is way easier now. For instance, one of the things that I didn't touch is obviously, maybe you want to do some validation. Yeah, you could put in fluent validation or whatever, which works great with generic types as well. You could actually implement that into that data store, that base data store, and have that system figure it out at runtime. This was not what I was going to show. Yeah, so here we have the same application. I mean, for the front, there is typically nothing changed except for the fact that under the hood we have separated the classes that are used on the front end in the data grid from the actual entity framework models, and we can have other validation settings on the DTO models besides versus the validation rules on the entity framework models. And yeah, there is a bit of an abstraction there, but for the front, yeah, the application is just the same. And yeah, so with this is the customer, by the way. So the customer ID is actually a lookup, which is calling that method that I was talking about, you see. And with this, I think I am pretty much done with explaining what I was going to explain. Let me see if the bullets, we have touched all the bullets here. Oh, I was going to explain what I was going to do. Yeah, and with this, I'm pretty much done in refactoring my code into generic abstract classes, which allows you to only implement the specific differences between implementations here and there. Yeah, and if you want to play around with this code, I mean, feel free. I have this full demo, inclusive the starting point as well as the end project. It is available on this GitHub repository. Yeah, check it out and see if you can use it in your own applications, if you can optimize your own code and make your code a bit more maintainable. So, are there any questions so far? In that case, thank you for your attention, and